Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve a theory paper of this subject. For this purpose, we have selected May-June 2024 Physics 5054 to 1 paper. This paper 2 belongs from the Zone 1. In this video, I'm going to present you the solution of this paper to the best of my knowledge and my abilities. So let's start today's paper. Before we start solving this paper, I want to give credit to the Cambridge Assessment International Education. You know, the paper and the marking scheme which we are using in this paper, they are the property of the Cambridge Assessment International Education. I have downloaded these papers and these marking schemes from their website. So this paper, the marking scheme, is the property of the Cambridge Assessment International Education. I am only presenting you the solution of this paper to the best of my knowledge and to the best of my abilities. So this paper is May-June 2024 to 1 paper. The time allowed for this paper is 1 hour and 45 minutes. The value of the G in this paper we will take as 9.8 meter per second square, or you can say 9.8 Newton per kg. The total marks for this paper are 80. Okay, so here we go. The question number 1 coming up on your screen. A ball is released from rest at point A and moves along a smooth track A, B, C, D, E as shown in the figure 1.1. The ball is shown at the point A, and as it passes point B, the ball is always in contact with the track and air resistance is negligible. The figure 1.2 shows the distance time graph for the ball as it moves from A to E. Okay, so here we have a distance time graph given on the figure 1.2. Mark with the letter P one point where the ball accelerates, with the letter Q one point where the ball has constant speed. Okay, so it's very simple. You know, this is the distance time graph. On the y-axis, the distance is represented, and on the x-axis, the time is represented. So what we will do, in the distance time graph, when the body accelerates, it is a curve, because the gradient of the distance time graph represents the velocity. So if the body is accelerating, the velocity will be increasing. So the gradient should be increasing. So that portion must be a curve and its gradient should be increasing. And where the speed is constant, this is their question. The second part they are asking is where the ball has a constant speed. So when the ball has a constant speed, that means the gradient of this distance time graph should also become constant. So you can see in this portion, the gradient remains constant. So here I can write Q, here the gradient is increasing. So here I can write P. Let's check. I have done this. So here we go. So at this portion, I will write, label it as P, and this portion I will label as Q. I hope you understand this. This is question number 1. The marking scheme of this paper is also showing up on your screen. This is how you do this. It's a distance time graph. Okay, so that was question number 1A part, first portion. He says in the second portion of the question number 1A part, determine the speed of the ball at the point X. On the figure 1.2, show your working. We have to find out the speed at the point of the X. So if you want to find out the speed at the point X, you know, this is a curve here. So first of all, I will draw a tangent here, and then I will take 2 points on that tangent, and I will find the gradient of that tangent. The gradient of that tangent will be equals to the speed of the body at the point X. So here you can see Can you see that at point X, what we have done? We have drawn a tangent at the point X. So this line is basically tangent. Then I will take 2 points on this tangent. For example, I have taken this point. This point is 0.5, comma 0.7. And this point, I have taken this point. This is 2, comma 3.7. So we will take these 2 points. We will note down their coordinates. We have first of all drawn the tangent, then we have noted down their coordinates. And on your screen, I hope you can see this clearly. We have taken 2 points on that tangent, 2, comma 3.7 and 0.5, comma 0.7. And then I will find the gradient of that tangent. The formula is y2 minus y1 divided by x2 minus x1. This formula you have studied in your mathematics. Here it will be d2 minus d1 divided by t2 minus t1. 3.7 minus 0.7 and divided by 2 minus 0.5. So it will be 3 divided by 1.5, and that is 2 meters per second. So the speed at the point X is 2 meters per second. They say the answer will be from 1.9 to 2.4. So our answer is in that range. So the answer is right. I hope you understand this. Okay. Then we have question number 1. It's B part. He said the speeds of the ball at the point A, B, C, and D are VA, VB, VC, and VD respectively. Arrange these 4 speeds from slowest to the fastest. So let's see, slowest to the fastest. The speed should be fastest. Here, the speed will be slowest. Here, the speed should be fastest. Here, the speed will be in middle. Here, it will be faster than the C, but less faster than the B. You know, this is the shape of that track. Here, the speed will be 0 or maybe very slow. Here, because it has came from that height, so here the speed will be the fastest. Here, the speed will be less than B, more than A, and the D will have speed less than B, but more than C. So according to this, slowest to fastest. So we will have the speed. The fastest speed will be A, then after the slowest speed will be at A, and then the slowest speed will be at the point C, and but means the speed at the C will be more than the speed of the A, and more than the speed of C, we will have the speed at D, and the fastest speed will be at the B. It's a little bit confusing, but I hope you understand. So our answer is right, sir. I hope you understood this is the shape of a track. Obviously, here the speed will be the fastest, then you will lose the speed. Here speed will be less than the B, but here the speed will again be higher because you have came up from the top of this track to this level. So at the D, the speed will be more than B, but less than C. Okay, so then we have question number 1. It's a C part. Work is done to transfer energy between energy stores as the ball moves from the point A to point B. Name the forces involved in the work done and describe the energy transfer. Okay, so when you move from point A to point A is at a higher level and the point B is at a lower level. So when you are at A, you have gravitational potential energy. So the weight will pull you down on that track. So what will happen? You will move down that track. So when you will be going from A to B, basically your gravitational potential energy will be converting into the kinetic energy, and because there might be some friction between the track, and if there is some friction between the track and that ball, so what will happen, some of the energy will be converted into thermal energy, but basically what will happen, the gravitational potential energy will convert into the kinetic energy. So at B, all the potential energy would have converted into kinetic energy. Oh, sorry. Okay, so let's check what the answer Y have written. At A, the ball has gravitational potential energy due to the gravitational force. Ball moves from A to B. Gravitational potential energy converts into the kinetic energy. I think they have said in the start of the question that there was no air resistance, so we have ignored uh, the thermal energy produced because there is no air resistance, and but they have not talked about the friction between the track and the ball. So I hope you understand this, and the marking scheme is also showing up on your screen. Okay, then we have another very important thing they are asking is the D part. Question number one is D part. He says the track at the point B is circular in shape. On the figure 1.1, draw an arrow to show the direction of the resultant force on the ball at the point B. So come here. So this track is basically circular here. So it's basically an imaginary circle. This thing is part of an imaginary circle. So whenever a body moves in a circle, the direction of the resultant force is always towards the center. For example, this is the center of that circle. Whenever you move in a circular track, the direction of the resultant force is always towards the center of that circle. So this is how you will show that resultant force. Remember this thing. Let me show you here. We have done that here. So here, so you see this resultant force at the point B, because this is a circular track here. The resultant force is always towards the center of that circular track. So you will draw the arrow like this. So you can see the marking scheme here. Question number one, D part. It says at the point D, we have drawn at the point, let me see. Let me see. Where we have, I think we made a mistake. Let me read the question. I thought they're talking about the point B, but I think they are talking about point D. The track at the point B is circular. No, in the question they said you have to draw an arrow at the point B. Look at this funny thing. In the marking scheme, he says arrows upward at the D. Okay, so this is this by mistake they said D. This is actually point B. This in the marking scheme is point B, not D. I thought we made a mistake. Okay, so you see, whenever we find some mistake, the first is that we might have made a mistake. Okay, question number two coming up on your screen. He says a small aircraft takes off from the horizontal deck of a ship. Before taking off, the aircraft is held in place by a hold back bar. When the hold back bar is released, the aircraft is pulled along the deck by a steam powered piston as shown in the figure 2.1. Okay, so this is the cable for the piston to pull aircraft. Okay, so this is basically pulling it, and this is the hold bar. So it's holding it, and this is the tank containing steam and the boiling water. So if you will release it, so what will happen? This steam will come here, and this piston will move very quickly in there towards the left. Okay, so this aeroplane will also move to the left. Okay, so this is the story. When the whole bar is released, the aircraft is pulled along the deck by a steam-powered piston as shown in the figure 2.1. Okay, so what is their question? The steam exerts a high pressure on the piston. So the steam which is in this container it is coming here and it's applying a pressure on this piston. Question number 2A, first part is explain using ideas about the particles how the steam creates a pressure on the piston. You see the particles of the steam, they are moving randomly. So during their random motion, what happens? They collide with the walls of this container and with the surface of the piston. So when they collide there, and so their momentum changes, the direction of their velocity changes. They strike and they go backward. They bounce from that piston, so their momentum changes. That's why a force is exerted on that piston. So that force exerted on the force which is exerted on per unit area of that piston, that causes the pressure by that steam particles. Okay, so let's check what we have written. And here we go. Okay, so my first answer is coming up. Question number 2A, first part. Particles of steam are moving randomly. Particles of steam collide with piston. During this collision, particles exert force on piston. This force per unit area is pressure. The force which is exerted on per unit area is called pressure. So let's check the marking scheme. Question number 2, it's A part, and let me increase the size. So, ooh. Okay, so I hope you have read the answer. So let's go to the next part. Question number 2A, second part. He says, explain why the pressure on the piston increases as the temperature of the steam increases. You see, when the temperature of the steam will increase, the particles of the steam, they will start moving faster. Their kinetic energy will be higher. So when two things will happen, their collision frequency with the walls of the piston will increase, and now because they have more kinetic energy, when they will collide with the walls of the piston, they will exert more force, they will hit more harder. So that's why the force per unit area will also increase, and the pressure of the gas inside that piston will increase. When the temperature increases, the kinetic energy of the steam particle increases, collision frequency of the steam particles with piston increases, particles hit harder with the piston. So that's why the force exerted per unit area will increase, and that's why the pressure of that steam will increase. Okay, so that was question number 2, and it's a second part. Okay, now we are going to the next part, question number 2, and it's B part. He says when the pressure is high enough, the hold back bar is released. The steam pushes the piston along the pipe shown in the figure 2.1. The piston has a cross-sectional area of 0.30 meters square. The pressure of the steam in the tank is 2.1 in expo 6 Pascal. Atmospheric pressure is 1 expo 5 Pascal. Determine the resultant force on the piston caused by the pressure difference. Show your working. Okay, so the pressure of the steam is 2.1 into 10 raised to power 6 Pascal. So, and the atmospheric pressure is 1 into 10 raised to power 5 Pascal. And we know the cross-sectional area of the piston. So, you know the pressure is equal to force divided by area. So we can find that force, that will be the pressure multiply area. So find the difference of the pressure between the steam and the atmospheric pressure, which is acting outside that piston. And that will be equal to force divided by area. So 2.1 expo 6 minus 1 expo 5, and that is equal to F divided by the 0.30. So 0.30 multiplied 2 expo 6, and that is 6 into 10 to the power 5 Newton. So 6 expo 5 Newton is the resultant force. 6 expo 5 Newton is the resultant force. We have found, first of all, the difference of the temperature inside and outside. Outside is the atmospheric pressure. Okay, the force calculated in the B causes the aircraft to accelerate to a maximum speed of 28 meters per second from rest. The mass of the aircraft is 3x per 4 kg. Calculate the momentum of the aircraft at the maximum speed. You know what is the formula for the momentum? The momentum is equal to the product of mass and velocity. We have the mass, we have the maximum velocity, we can find the maximum momentum. So here we go. Okay, so let's see, I have done this. Okay, the C part. Our momentum is equal to mass multiplied velocity, so 3x per 4 kg multiply 28 meter per second, and the answer will be 8.4 x per 5 kg meter per second. Then let's check first of all from the marking scheme. The answer is right. Okay. Okay, then we have, he says, calculate the time taken for the aircraft to reach the maximum speed. Uh, we know the resultant force, we know the mass, we can find the uh, okay. So here we are using that the force is equal to the rate of change of momentum. A force is equal to the final momentum minus initial momentum, the whole thing divided by time. And we know the resultant force, that is 6x per 5 Newton. And we know the final momentum, that is 8.4 10 raised to power 5 kg meter per second. The initial momentum is 0 because it was at rest, and the time we don't know. We want to find out. So time will be equals to 8.4 x per 5 divided by 6 x per 5, and that is 1.4. So 1.4 seconds. So remember, don't never forget this formula. The change in the momentum divided by time is equals to the resultant force. 1.4 second, they say. Our answer is also 1.4 second. So it's a perfect answer, sir. You can take your time with the marking scheme if you want more time. This is how we have done this. So we are done with the question number 2. Now we are moving to the question number 3. So question number 3 is showing up on your screen. A pan containing ice at minus 15 degrees centigrade is placed on a gas heater as shown in the figure 3.1. A part, he says, so this is a gas heater. Here we have a pan and we have placed ice cubes who are at minus 15 degrees centigrade and we are heating them. So A part, question number 3, A part, he says thermal conduction occurs in the metal from which the pan is made. By referring to the particle, describe the process of thermal conduction in a metal. So the thermal conduction in a metal, there are two things which support the conduction in a metal. One is because the metal is a solid, so the atoms, the particles of that metal, which are at the hot end, they absorb the energy, thermal energy, and the amplitude of their vibration increases, and they collide with the neighboring particles of the metal, and they make them vibrate vigorously, and their amplitude of vibration increases, and they make their neighbors vibrate vigorously, and their amplitude of vibration increases. And then what happens? The particles which are at the cold and they also start vibrating vigorously, and in this way, by the vibration of the particles, the energy is transferred from the hot end to the cold end. Another very important thing in the metal is that the metal has free electrons, and those free electrons do not associate themselves with a particular nucleus. So what happens? They can move in the body of the metal. So the free electrons which are at the hot end, they absorb the energy and they flow in the metal towards the cold end. And when they reach the cold end, they collide with the atoms there and they make those atoms vibrate vigorously. And in this way, by the flow of the electrons from the hot end to the cold end, the energy is transferred in the metals very quickly. So this is how this is done. So I hope you understand. So give me a okay, so let's check the answer written. We have written this answer. Okay, free electron diffusion takes place. That process in which the electrons move, that is called free electron diffusion. So free electron diffusion takes place and free electrons at hot end of the metal absorb energy and move to cold end of the metal. Electrons collide with the atoms of cold end and make those atoms vibrate vigorously. So this is question number 2. It's sorry, question number 3. It's A part. Question number 3. It's A part. I hope you understand this. Okay, let's move to the next part. He says the figure 3.2 shows how the temperature of the contents of the pan varies with the time. So when the time is 0, the temperature is -15 up to 2 seconds, 2 minutes, sorry. The temperature rises from -15 to 0 degrees centigrade, and then the ice cube starts melting from 2 to 20 minutes. The temperature remains constant. Here, the ice is melting, the temperature do not change. At 20 minutes, the temperature, that ice has melted completely. So it has converted into liquid. And then again, the temperature starts increasing from 20 to 24 seconds, from 20 to 24th second. The temperature is rising and the temperature has increased from 0 to 15 degrees centigrade. So this is the heating curve for those ice cubes. State the melting point temperature of the ice in the Kelvin. You know, in the degree centigrade, the temperature, the melting point of the ice is 0 degrees centigrade, but they are asking you to convert this into the Kelvin scale. If you want to convert degree centigrade into the Kelvin, you will add 273 in it. So K is equal to 273 plus C. K is equals to 2C plus sorry, not 273. I wrote here 270. This is not 270. This is supposed to be 273. And that is equals to the C is 0 plus 273. So 273 Kelvin. 273 Kelvin. 273 Kelvin. Okay, then their question is explain why the temperature of the water is constant as the ice melts. You see, when the ice is at its melting point, the heat you provide, that is not used to increase the temperature. That heat is basically used to overcome the intermolecular forces. That heat is used to break the intermolecular bonds. That heat is used to move the particles away from each other. So basically, we call this heat latent heat of fusion. So the heat you are providing has been absorbed as the latent heat of fusion. So the heat absorbed during the melting is a latent heat of fusion. This heat is used to weaken the intermolecular forces, move the particles apart, and increase the potential energy. Question number 3. And latent heat. Okay, so here the marking scheme is showing up for you. You can read the answer of question number 3B, second part. I hope you understand this. Okay, so we are going to the question number 3 is third part. The initial temperature, the initial mass of the ice in the fan is 1.5 kg, and the initial temperature is -15 degrees centigrade. The specific heat capacity of the ice is 2100 joules per kg per degree centigrade. Calculate the energy required to warm the ice to its melting temperature. Okay, so the melting temperature is 0 degrees centigrade. So your temperature will change from -15 degrees centigrade to 0 degrees centigrade. You can calculate the change in the temperature here because the change in the temperature is taking place. So we know that the heat, when the temperature is changing, we can calculate very simple formula. Heat is equals to mc delta theta, where m means the mass and the C means the specific heat capacity of the ice, and the delta theta means the change in the temperature. So heat is equal to mc delta theta. So the mass is 1.5 kg. C is 2100 joules per kg per degree centigrade. And the change in the temperature is 0 minus 15. So that's 15. So 1.5 multiply 2100 multiply 15. That is 47,250 joule. So when you round it off to two significant figures, it will be 47,000 joule. 47,000 joule is the right answer. So this is how this is done. So we are moving to the next part. That is question number 3 and its fourth part. All the energy transfer to the fan comes from the heater. Using your answer to the third and the figure 3.2, determine the power of the heater used to warm the ice. To warm the ice, you took 2 minutes, which means 120 seconds. From where I'm getting that time from that graph. And that graph, it took 2 minutes to change the temperature from minus 15 to 0 degrees centigrade. 2 minutes means 120 seconds. So the heat divided by time, that is equals to the power. So the power is equals to the energy divided by time. So 47,000 joules divided by 120 seconds, that is 391.7 watt. So when you round it off, it is almost 390 watt into significant figures. So 390 watt is the right answer, sir. Okay, so we are going to the question number 3 and its fifth part. He says the graph in the figure 3.2 has a smaller gradient when the water is liquid than when it is solid. So that's one reason why when the water is in the liquid form, its gradient will be smaller in the heating curve. The reason is the water has a higher specific heat capacity. So the ice has less specific heat capacity and the water has higher specific heat capacity. The water will require more energy to raise its temperature as compared to the same rise in the temperature in the ice will require less amount of heat. Specific heat capacity of the water is higher than specific heat capacity of the ice. So this is question number 3B, fifth part, and I hope you understand this. Okay, so we are going to the next question. That is question number 4. He says the ultrasound of the frequency 30 kilohertz has a wavelength of 0.011 meter in air. So what is meant by the frequency? Frequency is the number of the waves passing through a point in unit time or in 1 second. So that's the definition of the number of the complete waves passing from a point in unit time. So this is question number 4. I hope you understand this. This is definition of the frequency. And question number 4 is second part. Calculate the speed of the ultrasound in the air. Show your working. We know the frequency of the ultrasound, that's 30 kilohertz, and which means 30,000 hertz. And wavelength is 0.011 meters. Lambda is given, frequency is given. You know the wave equation, V equals to F lambda. So we can find the V, which is speed, V equals to F lambda. So on your screen is showing up V is equal to F lambda. So 30,000 multiplied 0.011, and that is 330 meter per second. So the speed of the ultrasound in the air is 330 meter per second. So our answer is right. I hope you understand. Okay. Then their question number 4 is third part. State one use of the ultrasound. The one use of the ultrasound is that the ultrasound is used for cleaning the jewelry. Ultrasound is also used for the prenatal scanning. You can write. Ultrasound is used for the prenatal scanning. So there are a lot of yeah, you can look at the marking scheme here. Okay, so we are going to the question number 4. It's a B part. Here he says, B first part. Sound waves are longitudinal waves. Water waves are transverse waves. Describe by referring to the movement of the particles in the wave, the difference between a longitudinal wave and a transverse wave. You may include a label diagram to help your description. So very simple. We can draw. It's a 3 marks question. Okay, so let me show you my answer here. So hopefully, you can see here, I have drawn here the particles. Here we have compressions, rarefactions, compressions, rarefactions, compressions, rarefactions. This is a longitudinal wave. Here we have shown a transverse wave. The transverse wave consists of crust and troughs, crust and troughs. In the, you see, and here the particles of the medium, and the wave is going towards the right, and the particles of the medium are moving parallel to the direction. They are vibrating basically to the parallel to the direction of the wave. And in the transverse wave, the wave is going towards the right, so the particles of the medium are moving perpendicular to the direction of the wave. So draw these diagrams. In transverse waves, the particles vibrate perpendicular to the direction of the wave. In the longitudinal waves, the particles vibrate parallel to the direction of the wave. This is a very famous question. I hope you understand. Okay, then we have, this was question number 4B. First part, here we have question number 4B. Second part, state one source of waves that generate both longitudinal and transverse waves. Whenever the earthquake comes, it produces seismic waves, and the seismic waves are P waves and S waves, primary waves and secondary waves. The primary waves are longitudinal, and the secondary waves are transverse waves. So seismic waves produced by the earthquake. Okay, so okay. So question number 4C part, he says, figure 4.1 shows the radio waves of long and short wavelength passing over the same hill. Explain why the radio waves in the diagram A reach the house, but the radio waves in the diagram B do not reach the house. Is a 2 marks question. And the reason is very simple. The waves will have a longer wavelength, they will show more diffraction, and the waves with the smaller wavelength will show less diffraction. So when they show larger diffraction, so they bend more. So that's why they are able, at whatever obstacle comes in their path, so at the obstacle, they bend more, the waves with a longer wavelength. So they are able to reach the house here. The short waves, they do not bend that much. They do not show diffraction that much. So that's why they are not able to reach the home. The shorter wavelength waves do less diffraction. Longer wavelength waves do more diffraction. Longer wavelength waves after diffraction are able to reach house in the figure 4.1. The marking scheme is showing up for you. I hope you understand. You can take your time if you need more time with this marking scheme. Okay, so we are moving to the next question. The next question coming up on your screen is question number 5. It says figure 5.1 shows part of a circuit containing 240-volt mains supply connected to a lamp and two heaters of the resistors 40 ohm and 60 ohm. Okay, so the main supply alternating current is being provided here. We have a lamp here. We have two heaters here. One has a resistance of 40 ohm. The other one has a resistance of 60 ohm. So these three are connected parallel to each other. Plus they are connected parallel to the 240-volt AC main supply. Complete the figure 5.1 by drawing the symbol of a fuse in the gap in the circuit. The symbol of the fuse is a rectangle, and in the rectangle you pass a line. And here, this is the symbol for the fuse. You have to draw this. This is a 1 mark question, and the marking scheme is, here we have the marking scheme. Okay, so then we have question number 5, and it's B part. He says, first portion, on the figure 5.2, sketch a current voltage graph for a filament lamp. The current is on the y-axis and the voltage is on the x-axis. The gradient here is equals to the reciprocal of the resistance. So that curve will be its slope, its gradient will gradually decrease because the resistance of the filament lamp increases with the increase in the voltage and the current. So the gradient, because the gradient of the this graph represents the reciprocal of the resistance. So that's why the gradient should gradually decrease. So you will draw this graph of this shape. This is a very famous diagram. This is also present. These graphs are also present in your text book. Okay, so here we go. Okay, so we are going to the next part. Question number 5B, second part. Explain the shape of the current voltage graph drawn in the figure. It's a 2 marks question. I think that the gradient of the current voltage graph, this current voltage graph, is equals to the 1 by R, reciprocal of the resistance. So this shape here, you can see the gradient of this graph is gradually decreasing. As you increase the voltage, the gradient is decreasing. That means the opposite thing is happening with the resistor, the resistance of the lamp. That means as you increase the voltage, the resistance of the lamp increases. So here I have written the answer. He says the gradient of the current voltage graph is equals to 1 by R. Gradient gradually decreases, which mean resistance increases as voltage increases, temperature increases as well. So let's check the answers. The answer of the question of 5B, second part is showing up. I hope you can take your time and read that. So this is my answer. Question number 5, it's C part. He says, calculate the current at the point P in the circuit shown in the figure 5.1. So we have to calculate how much is the current flowing in the point P. So I know the resistance here. I know the resistance here. And because these are parallel to this 240 volt, the voltage drop here is 240. This is concept. The voltage drop here will be also 240 volt, and the voltage drop here will be also 240 volt. So if I know the voltage drop here, I know the resistance here, I can find out the current in this heater. If I know the resistance here, I know the voltage drop here, I can calculate the resistance here. V is equals to I R. So if we can find the I, then both the I's will be added up, and that will be equals to the current at the point B. So at the heater 1, P is equals to IV, V is equals to IR, Ohm's law. So I will be equals to V divided by R. So I will be equals to 240 divided by 40, that is 6 ampere. So in the first heater, the current flowing is 6 ampere. In the heater number 2, V is equals to IR, I is equals to V by R. So I is equals to 40 divided by 60. So that is 4 ampere. So in one heater, the amount of the current is 6 ampere. In the other heater, the amount of the current is 4 ampere. So at the point, the current will be equals to the sum of the current in those two branches. So 6 ampere plus 4 ampere, and that will be 10 ampere. So the current at the point will be equals to 10 ampere. And you can look at the marking scheme. Our answer is right. Okay, I hope you understand. So we are going to the next part. This is question number, this is which question? This is question number 5, and it's D part. He says, okay. So D part, he says, the current in the lamp is 1.5 ampere. Suggest a suitable fuse rating for the fuse. Now we know the current in the 3 branches in the lamp, the current is 1.5 ampere. In one heater, the current is 6 amperes. In the other heater, the current is 4 amperes. So the total current coming from the battery is 6 plus 4 plus 1.5. So that is 11.5 ampere. So the fuse must be more than 11.5 ampere. It can be 13 ampere. It can be anything more than 11.5 ampere. So first of all, we calculated how much is the current coming from the battery. We know the current in the 3 branches there. So the current coming from the battery is the sum of the current in those 3 branches. So that is 6 plus 4 plus 1.5. That's 11.5 ampere. The rating of the fuse must be more than 11.5 ampere. So famous rating of the fuse is 13 ampere. So our answer is right. Okay, sir. So question number 5D part, its second portion. Explain why a fuse rating much larger than the value in the first is not suitable. If you use a fuse of the rating much higher than the current which is needed in the circuit, then what will happen if there is a short circuit and there is excess amount of current going, there's a surge of current going into that circuit, but because the fuse will not blow because the rating of the fuse is higher. So the it's not a sensible thing to use a fuse whose rating is much larger than the normal current which that circuit needs, because the fuse then will not blow in the case of a surge of current or a short circuit. Explain why if more than 12 ampere current will flow into the circuit, fuse of much larger rating might not melt, but circuit and lamps might be harmed. So if there is a short circuit, your lamps might be harmed, but the fuse will not blow. Okay, I hope you understand this idea. Question number 5 and D, and its D part and its third portion. Explain why it is necessary to connect a fuse in the live wire rather than the neutral wire or earth wire. The fuse, the switches, they are always connected in the live wire, so that when the fuse blows, when the fuse is melted, your appliance, for example, heater, your lamps, they are isolated from the live high voltage current. If you put the fuse in the neutral, the appliances and the lamp, the fuses here, they will not be isolated from the high voltage live current. So that when the fuse melt blows, your electric equipment is isolated from live current. So this is our answer. So you can look at the marking scheme of the question number 5D, third part. I hope you understand this. Okay, so we are moving to the next question. The next question coming up on your screen is question number 6. He says figure 6.1 shows figure 6.1 shows the structure of a simple electric motor. So here you have a coil inside two poles of magnet, and here you have that coil. So here you have that uh, what we call it, split ring commutator, and then you have carbon brushes and you have connected them with the battery. He says that the current in the coil causes the coil to rotate. A student notices that the coil turns in the direction shown by the curved arrow in the figure 6.1. So the coil is basically rotating clockwise. Okay. State what happens to the motor if a stronger magnet is used. When you will use a stronger magnet, the turning effect will increase and the coil will rotate faster, I think. So question number 6 and its A part is coming up on your screen. So the turning effect experienced by the coil will increase. The coil will rotate faster. It will turn faster. Okay. So then they say on the figure 6.1, mark and label the direction of the current in the coil, the direction of the magnetic field. It's a 1 mark question. So let's direction of the current. The current is coming from the positive, so of the terminal of the battery. So the current is coming from here and through this. So the current is going in this direction. Okay, the current is going in this direction. And from negative end, it will come back. From positive, the current will go into the coil. Okay, the direction of the magnetic field is from north to south. Let me show you. I have done this. Okay, so the current is going from the positive terminal of the battery, and you can see, and the magnetic field is going from north to south. I hope you can understand this. Okay. Okay. So Then the question is question number 6. It's A part, and question number 6, A part is third portion. It says explain why the coil turns. You see, when you pass the current through that coil is inside a magnetic field. So the side of the coil is a current carrying conductor placed perpendicular to the direction of a magnetic field. So it will experience a force on it, which will be perpendicular to both the current and the magnetic field. And we call this motor effect. And the direction of that force can be found by using the left hand rule. And so that coil will turn. So let's see. There are two ways of explaining that why the coil will turn. One is this way, which I just explained to you. Other way is also that the current, the side of the coil has a current flowing through it. So it has a magnetic field. It has circular magnetic field around it. So when that circular magnetic field and the magnetic field of those permanent magnets interact with each other, so due to that interaction, the a force is created in one particular direction. Right side of the coil is a current carrying conductor placed. So we are using the right side of the coil to explain our point. Right side of the coil in a left side also has current. Right side of the coil is a current carrying conductor placed in the magnetic field. It experiences a force in a downward direction. Left side of the coil is also a current carrying conductor in a magnetic field, experiences a force in upward direction, and that happens because of the motor effect. Okay, so you can look at the marking scheme here. You can read, you can pause the video and you can read these. Okay, so I think this is the answer. So we are going to the next part. The question number 6, B part. It says two vertical wires carry equal current in opposite directions. They pass at right angles through a piece of the card as shown in the figure 6.2. So this right side wire, it has an upward current, and this left side wire has a direction of the current in it is downwards. And you know, the wire which is going in, the right side wire, in the current is going upward. It's like so here we have a top view of that paper. So figure 6.3 is a view of the card from above, and the dot here means that this wire has a current coming out of this page, this card, and this cross means that the current is downward into the card. Okay, on the figure 6.3, sketch the pattern of the magnetic field produced. You can use your right hand. You can hold this conductor in your right hand in such a way that your thumb is in the direction of the current, and then the curves of your finger of your right hand will show the direction of the magnetic field. So okay, so if you hold this right side coil, because the current direction is out of this screen, so hold it in your right hand in such a way that the thumb is out of the screen. Then the curves of the right hand will show the direction of the magnetic field around it. So they will be anti-clockwise. And this wire, which is showing the current going into the page, so hold it in your right hand in such a way that your thumb is in the direction of that conventional current going into the screen or into the paper. Then the curves of your right hand will show the direction of the magnetic field formed around it, and that will be clockwise. So we have to show this. I have done this. I have told you that by using the right hand rule, we are able to find. And you can see here around this wire, we have shown anti-clockwise, and here the magnetic field has been shown clockwise. And how do I know that this is clockwise, this is anti-clockwise? This is because of I'm using the right hand grip rule for the straight conductors. I hope you have studied that. So let's check the marking scheme. So when you are near the coil, these circles should be close to each other. When you are away from the coil, the distance between the circles should become a little larger. Okay, so then we have question number 6. It's a part, and its second portion. He says the currents in the two wires cause the wires to repel each other. Explain how the current in the one wire causes a force on the other wire. So you see in the middle here, the direction of the magnetic field is same due to both these. They both have the same direction of the magnetic field here. So the magnetic lines here will become very close to each other. So the magnetic field here will become very strong, and on the sides the magnetic field will be relatively weak. So both these wire will experience a force in outward direction. So this wire will move to the experience a force towards the right, and this wire will experience a force towards the left. This is one of the explanations. Another explanation can be, if you think about this wire is a current carrying wire. It's a current carrying conductor placed in the magnetic field of here, this magnetic field, the magnetic field due to this wire. This is a current carrying conductor which is placed in the magnetic field due to this current. So due to the motor effect, this will experience a force on it. It's a 2 marks question. Wire on the right side is the current carrying conductor placed in the magnetic field of the wire on the left. Right side wire experiences a force to the right. It will be repelled. Ooh, so I think we are done with this. I gave you both the explanations. Okay, so we are going to the next question. The next question is question number 7, table A part. Table 7.1 shows different nuclei. So thorium 236, 9236, protactinium 236 is protactinium 91 236. Uranium 235 is uranium 92 235, and uranium 238 is uranium 92 238. State which two nuclei have the same number of protons. So the names, so these lower numbers, they are representing the number of protons. So which two have the same number of protons? Uranium 235 and uranium 238. Uranium 235 and uranium 238 have the same proton number. So let's open the marking scheme as well. Okay, so here we go, here we go. Then he says state which two nuclei have the same number of neutrons. How you find the number of neutrons? From this mass, a number of nucleons, subtract the number of protons. So, so I will be able to find out the number of the neutrons. So 236 minus 90, that's 146. 236 minus 91, that is 145. 235 minus 92, that is 143. And 238 minus 92, that is 146. Their questions were that the question was that which two have the same number of neutrons. So 146, 146, thorium 236 and uranium 238, they both have the same number of neutrons in them. Okay, their next third part is question number 7. State which two nuclei have the same number of nucleons whose mass number is same. So 236, 236. Okay, so thorium 236 and protactinium 236 have the same nucleon number. So here we have the thorium 236 and the protactinium 236 have the same nucleon number. Okay, so that is question number 7A part. Now we are on the question number 7B part. He says, a teacher uses a Geiger-Müller tube and a counter to measure the background radiation in the laboratory. The counter records 20 counts per minute. So that's the background radiation, 20. A radioactive source is then placed in front of the tube and the counter records 420 counts per minute. So state what is meant by the background radiation. Background radiation is that radiation which is all the time present around us without any source of the radiation nearby. A radiation which is present in the in an environment naturally all the time. So that is called the background radiation. Okay, so let's go the question number 7b and its second part. Is it the measured count rate of 420 counts per minute can be corrected for background radiation? Calculate the corrected count rate for the source. So the reading on the GM tube is 420 counts. So 20 counts is for the background radiation due to background radiation. So from 420 we will subtract 20. So the 400 is the corrected count rate from the source. So 420 minus 2, 420 minus 20, and the 400 is the corrected count rate of the source. So 400 is the right answer, sir. Okay, so then we have the radioactive source has a half-life of 45 minutes. Determine the reading on the counter 90 minutes later. So the half-life is 45 minutes. So after every after every 45 minutes, the thing will become half. So the count rate due to the source is 400. So after 45 minutes, it will become half. It will become 200. When another 45 minutes have passed, it will further half. So it will become 100. So the reading on the GUM2 will be 100 due to the source plus the 20 due to the background. And the reading on the GM tube will be 120 counts per minute. 120 counts per minute. Our answer is right. I hope you understand. And the half-life is applied to the reading, which is purely due to the source. So just why your answer in this in answer to the third part is only an estimate. It's only an estimate because the radioactive decay is a random process. It do not remain all the time same. So it changes, it has fluctuations, and the answer is showing up on your screen. The radioactive decay is a random process. Figure 7.1 shows different, this is the C part. Figure 7.1 shows different uses of 3 different types of radiation. Draw a line on the figure 7.1 from each use of radiation to the type of radiation used. One line uh, uh, one, from each use of radiation to the type of radiation used, one line has been drawn for you. So each type of radiation can be used once, more than once, or not at all. So household fire smoke alarm, they use alpha particles because the alpha particles have very low penetration power. So irradiation food to kill bacteria and sterilization of the equipment, and for that purpose gamma radiation is used. Measuring paper thickness, for that also the 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 gamma radiation and the beta particles can be used. Okay, for sterilization I know the gamma radiation is used. Okay, so for household fire smoke alarms we use alpha particle. For irradiating the food to kill the bacteria we use the gamma radiation. For sterilization of the equipment we use gamma radiation. For measuring the paper thickness we use beta particles. Okay, so this is our answers. So I hope you understand this. Okay, so here we have the next question coming up on your screen. That is question number. The question number 8 is showing up. He says the table 8.1 shows data about the 3 planets, Mercury, Venus, and Earth. Okay, Mercury, Venus, and the time of the one orbit of the Sun in days is for Mercury it is 88 days, for Venus it is 220 days, and for the Earth it is 365 days. Distance from the Sun, the Mercury its distance from the Sun is 5.8 expo 7 kilometer. For Venus it is 1.1 expo 8 kilometer, and for the Earth it is 1.5 expo 8 kilometer. And the average density, the Mercury's average density is 5400 kg per meter cube. Venus average density is 5200 kg per meter cube, and the average density of the Earth is 5500 kg per meter cube. Gravitational field strength at the surface of the Mercury is 3.7, and at the Venus it is 8.9, and at the Earth it is 9.8 Newton per kg. A part is figure 8.1 shows these planets in alignment with the sun. They rotate around the sun in the direction shown. Mark and label on the figure 8.1 the position of three planets 110 days after the position shown in the figure 8.1. So we have to show their position after 110. How many days? 110 days. So I will have to find out the angle that planet would have moved around the sun for 110 divided by 88 multiply 360, you will get the angle for the Mercury. 220 divided by 110 multiply 360, you will get the angle which the Venus has moved around the sun, and 365 divided by 110 multiply 360. Am I right? No, 110 divided by 360 multiply, 365. Let me show you. Yeah. For Mercury, sorry, I said something wrong, I think. 110 divided by 88 multiply 360. So the Mercury would have moved 450 degrees around the sun. And Venus 110 divided by 220, because in 220 days it completes 360 degrees. So in 110 days, it will complete only 180 degrees. For Earth, it will be 110 divided by 365 multiplied by 360, and that is 108 degrees. So we will have to show this, and because 450 angle do not exist, 450 means you have done one complete circle around the sun, and so you will from 450, first of all, we will subtract 360. So the remaining will be 90 degree. So for the Mercury, you see the Mercury is here. So the Mercury is here. So after so it will complete one cycle, and here 360 completed, then extra 90 degrees. So the Mercury will be here. Whatever is the distance in this direction, same is the distance in this direction. The Venus, it has to move how many angle? I forgot. For Venus, the angle is 180 degree. So Venus 180 degree will be here. So whatever is the distance on this side, same, keep the distance same here. Okay. And the Earth has moved how many angle? 108 degrees. So Earth is originally here. So with the help of the, protector, and mark 108 degrees, and here, whatever, this is the angle 108. This angle is basically 108. So whatever is this distance, show the same distance here. So this is how you will show the position of these around the sun. So we found the angle for each planet, that how much angle it has moved. I hope you understand this. So, okay. So we are on the question number 8B, first part. Each of the three planets has a similar average density. Suggest why the gravitational field strength at the surface of the Mercury is much smaller than at the surface of the Venus. This is because of the total mass of the Mercury. Because the Mercury has less mass, that's why it will have less gravitational field strength. Okay, the mass of the Mercury is smaller than the mass of the Venus, and that is the reason. Okay, so, okay. The bodies which have less mass will have less gravitational attraction. Okay, question number 8, and it's B, second part. An object has a weight of 37 Newton on the surface of the Mercury. Calculate its weight on the surface of the Earth. Show your working. So on the mercury, if I know the weight, I know the G value there, that is 3.7. And I want to find out what is the mass of that body on mercury. So 37 divided by 3.7, so 10 kg. You know about the mass. The important thing is that the mass do not change whether you are on mercury or you are on earth. So same mass on the earth, but the G value on the earth is 9.8. So 10 into 9.8, that is 98 Newton. So the weight on the earth of the same object will be 98 Newton, which was 37 Newton on the mercury. So I hope you understand. He says, state what is meant by a moon. Moon is basically a natural satellite which is orbiting a planet. So a large natural object that orbits a planet. Okay. Okay. Then the question is, the sun will eventually run out of hydrogen. Describe what happens to the sun when the hydrogen runs out. You know, the sun is a medium-sized star. It's a medium-sized star. This is one very important thing, because the life cycle of the medium star and the life cycle of the larger star is little different from each other. So when the when the sun will run out of fuel to burn, it swells in size and transforms into a red giant as it attempts to fuse heavier and heavier elements. It becomes increasingly unstable and eventually puffs, puffs of material, forming a short-lived planetary nebula. At the end, sun will become a white dwarf. So I hope you remember this. This is D part. Question number: becomes a red giant, increase in size, forms a planetary nebula, becomes a white dwarf. So this is, you have to remember, this is space physics. It's very, very important. Oh, my dear students, we have reached the end of this paper. So, my dear students, we have completed the solution of this paper. Let's check once again if we are not mistaken. There are only 8 questions in this paper. We have reached the end of this paper, yes. So in this video, I have presented you the solution of this paper to the best of my knowledge, to the best of my abilities. One thing is very important to tell everyone, and YouTube also, that the paper and the marking scheme which I have used in this video, that was the property of the Cambridge Assessment International Education. I have simply downloaded that paper and that marking scheme from their website. So this is their intellectual property, not mine. I'm not claiming it. So I have only written the solution to the best of my knowledge, my abilities, my skills. And the purpose of this video is to help you to prepare for your exam. And the most important thing about this paper, May, June 2024, 2-1 paper, that this paper was struck down by the Cambridge. So the YouTube took off this video, and now I have recorded this video again, and I am uploading this video again because the Cambridge claimed for the copyright. So, but now I am giving credit in all my videos that the papers and the marking scheme, they are the property of the Cambridge, and we are only presenting you the solution, and we are only, the purpose of this video is to help the students all around the world to prepare for the O-level physics exams free of cost. All they need is access to the internet. So thank you very much. If you find this video useful, interesting, please share the link of this video with your friends, with your teachers, with your junior students, with your senior students. Share the link of this video on your WhatsApp, on your TikTok, on your Snapchat, on your Instagram, on your LinkedIn. You know, when you share the link of this video, when you like this video, when you subscribe my channel, you basically support my work. Your support is very important. So everyone, thank you very much. Have a good day. God bless you all, and good luck for the physics exam.